spinal cord is the body's information superhighway, constantly buzzing with electrochemical signals between the brain and the rest of the body. This precious bundle of nerve fibres runs through a cavity within each vertebra. This protects the cord along its length, but even this bony armour can't protect the spinal cord from the worst injuries. With enough force, this delicate cord can get damaged, cutting off all communication to and from the body below the injury site, leaving a patient paralysed. This devastating injury happens to an estimated 500,000 people each year across the globe. To make things worse, the damage is irreversible. Neurons of the central nervous system don't seem to be able to regrow their axons, the long spindly projections that link them to other neurons. Scientists are currently working to understand why these injured nerves can't repair themselves and regrow their axons. At the same time, researchers are trying to reboot the regeneration process. So far, most of the research has been done on rodents, with researchers using 3 broad approaches to try to tackle the problem. The first strategy is to change the environment swirling round the damaged nerves to make it more growth-friendly by dialing down chemicals that inhibit the ability of nerves to regenerate. One set of molecules that are suspected of blocking regeneration are called chondroitin sulfate proteoglycans, CSPGs. Scientists have shown that by using an enzyme called chondroitinase, they can change the structure of the CSPG molecules so that they no longer block the growth of axons. The second strategy is to introduce factors that work directly on the cellular machinery of the damaged neurons to boost their capacity to heal themselves. For example, researchers are trying to make the neurons more receptive to pro-growth signals from their neighbours. Receptor molecules called integrins seem to disappear as neurons mature, so researchers are looking for ways to smuggle integrins back into damaged neurons. Researchers are also experimenting with adding in the growth factors themselves. For example, proteins IGF-1 and osteopontin have again been shown to spark axon regrowth. A third strategy has the potential to combine many aspects of the first 2. A study in rats has shown that mesenchymal stem cells, or MSCs, naturally home in on the site of injury and protect against secondary damage caused by the immune system. They also appear to promote axon regeneration, repair damage to the axon's insulating layer of myelin, and may be able to directly transform into new neurons. A small trial using MSCs in humans was completed last year, and the results are due to be reported soon. It's likely that a successful therapy will involve a combination of these ideas, hopefully giving patients with spinal cord injuries a brighter future.
Jeffrey B. The Locks, welcome. It is September the 2nd, straight after Labor Day holiday weekend, and actually Labor Day today, I guess. That video was great, and it shows you a couple of different approaches for regenerating the spinal cord nerves, axons, and all of that stuff. Now, what we're going to be looking at here is we're going to be looking at the second way, the mesenchymal stem cells. And what I want to mention briefly here is that my cousin and I are going on the Holy Grail quest, the adventure of a lifetime, going to seek out these mesenchymal stem cells, these stem cells, because in this country, the United States, it is so behind times when it comes to stem cell research. The FDA, federal government, will only fund projects that are based on certain very restrictive sources of stem cells. Whereas other countries outside of this little narrow-minded place have so many more opportunities to produce new stem cell lines that can help people with SCI, spinal cord injury, like my cousin. So what I want to do is I want to show you here exactly the sources of the different stem cells, where they can come from. So this is very important. You can see there, some of those come from embryos, some of those come from the umbilicus, the umbilical cord, some come from adipose tissue, and a variety of other sources. You can look on this slide and see where all the different ones come from to derive stem cells. that can be used to treat spinal cord injury. As the video described, it's just a matter of getting those stem cells into the site, the injury, and then they have very, very magical abilities. They're pluripotent, totipotent, meaning that they can differentiate into other cell types, whereas already fully differentiated cells cannot. The video explains it all, but I'm just kind of confirming. I'm showing you in the slide there the sources of stem cells. So we're going to be going to Asia to procure these stem cells and perhaps have a procedure done if we can find a doctor that is going to perform the surgery for a decent price. So that is going to be a mission. It is going to be a very important mission during this trip. So we will be focusing on finding those and getting a surgeon who can implant those. Of course, one of the biggest hurdles to doing this will be obviously cleaning up the wound, the primary injury site, which will have a lot of scar tissue around that. And what the doctor's going to have to get in, use a scope, and just clear all of that out, break it down, suck it out, and get rid of all the scar tissue that's blocking the axons, the neurons from signaling anymore and reaching the rest of the body downstream. After the site of injury, beyond that site, downstream of that's been blocked by the scar tissue and other molecular factors as have been described in the video. So again, the main reason we have to do this is because the stem cell research in this country is so terrible. It's restricted to certain labs, certain individuals, and that cannot be funded by the government because it only allows for certain types. And that goes all the way back, certain sources of stem cells, those from excess IFS in vitro fertilization, ones who may be used for that, you can only use them from there, and none of these other sources, basically. So extremely restrictive, terribly so. And we will be circumventing that by leaving this country, getting away from their bullshit policy, which stretches all the way back to the George W. Bush era. Thank you, Republicans, and all the ethical bullshit reasons they put on that, who have caused so many people in America the inability to have any hope of walking again in this country unless they leave. It's terrible stuff. Regeneration medicine here is just appallingly slow and just non-existent. Terrible, terrible. So we're going on this mission. We're going to be doing it soon. And so if you guys could help, click that donate button, contribute to the cause. We're going to need to raise some money for hiring the doctor, for procuring the stem cells. But we're going to do something. We're going to get somewhere. We will make some progress on this. So that's basically all we have, really, except this other. You can see where this goes. As you can see in the video, you had an injection of the stem cells, but you can see also in this diagram here where the stem cells can be injected as well. You can see this shows you a site of injury, and then what are the consequences, what we're actually looking at in this slide as well. I mean, basically what I just wanted to, get you informed about what this involves, what this entails. Yes, stem cells, you probably heard in some, Christian circles or conservative circles that you don't want to use stem cells because you're killing an unborn embryo or, and this and that. Okay. Yeah, there's that aspect of it too. And if you don't want people to walk again, you can continue to believe that. But, stem cells have an extremely important function and role in helping others. And there are a lot of different sources, as I showed you, for getting these stem cells. So we'll be able to obtain some of these. I don't know exactly the ones from which source. It doesn't really matter. If we can get some mesenchymal stem cells, get a doctor on board, and get the surgery going. Basically, the first thing you've got to do with the surgery is he's going to have his scar tissue cleared out, and then we're going to have to implant the stem cells. Now, the Verita Neuro place is a possibility. We will be exploring that in Bangkok, Thailand, and then we'll be probably going up to Chiang Mai, where we'll locate resources like stem cells and discuss with doctors from around that area, including Laos, Cambodia, Thailand, Burma, and even China. We have a lot of choices in that area. We'll be in discussion with various doctors from around there and try to get some more information. So there you go. This is all part of the live on experience. You want to live on and you want to do it in style, which means walking. Of course, my cousin has started the process of patient registry for the Neuralink. That's a good backup plan. So this is all about having a good, brighter future, and spinal cord regeneration is part of that. So that's all we have today. And until next time, live on.